All right, today, let me make sure I know how to use this. Okay. We're going to be talking about what it looks like to take everything we've been talking about so far and apply it to an existing ecosystem. And my name is Jan Flowers. I guess I should back up and introduce myself because I don't know a lot of you, but my name is Jan Flowers. I'm a faculty member of University of Washington, and I oversee a global health informatics center there, where we work both at the domain level on standards, working with OpenHIE and how to apply those standards, and then working with implementing organizations and countries to figure out actually how to bring this to fruition in the real world, right? Because we know standards are theoretical, and they don't always work in the real world. So we're going to talk a little more about that today. Okay, I'm going to start by just talking about this piece of paper. And I thought about making you all do a bit of an exercise by doing a drawing, but I'll just walk through it. If you'd like to draw, you're welcome to. But what do we do with a blank piece of paper? Isn't it wonderful? Wouldn't it be nice to have a blank piece of paper when we get up every day and we can just do what we want? In this room, there's plenty of what I would call artists. We're all informaticists. We may not use paintbrush, we may not use pen and ink, but we're all artists in health informatics, right? And we know how to apply what we know in an artful way to make everything come together, from using all this theory and these standards and beautiful designs that we come up with in order to make that pattern that we'd like to use, right? Like OpenHIE. But it's pretty rare that we start with a blank slate. Is anybody in this room working in a country where there's no digital health systems? Raise your hand. If I see one, I will be so surprised, right? I mean, we're talking about 2 decades plus, 3 decades in some countries, of digital health innovations, right? The landscape is messy. We don't have a blank piece of paper. So if I gave you a blank piece of paper, you might, and said, oh, just draw a giraffe, or make a paper airplane, or use this piece of paper to do something, you could do that with that blank piece of paper. After you did that and drew the giraffe or made a paper airplane, and I said, oh, now take that drawing of a giraffe and turn that into a car. Well, that's a lot more difficult, right? That's what we're working with. We're building on the backs of giants. We've heard that multiple times this week. Most of you have been working in digital health for a long time. And we took what we knew at the time that we did this and applied it in the best way possible to build systems with the needs and the pressures and the context that existed at that time. But as digital health has matured and our understanding of how to do things has matured, we know now that we need to change some things and we need to mature the ecosystem overall. So this is the hard part. And I was just laughing with Chris Seabricks. He went to the other room, but I'll call him out here. He was like, yeah, definitely we can talk a lot about this. And he goes, I said, yeah, what do you do? Oh, there's Chris. I said, what do? You cry, you wring your hands, right? You hide from the phone like, oh God, how am I gonna do this, right? But lucky for us and fortunate for us, we've learned some things, right? So we've started off looking at software data silos. We have a lot of those still in existence. Many of you will go back home to your countries and you're gonna start wringing your hands going, gosh, that conference was great. There's some great designs and great ideas and standards are wonderful. We've heard all about it. But I have all this, right? How do we go to that design we want? The key and the goal here is really about minimizing risk, right? So we don't want to just blow up the entire ecosystem. We actually want to pause and think about this in a way that we're going to minimize that risk to reduce disruption so we don't harm patients, so we don't upset our funders and upset our Ministry of Health with not being able to get indicators and understanding to them, not being able to get data to the clinicians. And we also don't want an extreme burden of costs in order to replace everything. So how do we do that? We also have to consider all the existing pressures and limitations like financial constraints, capacity constraints, looking at your health program needs, looking at the requirements of data and the timeliness of that data. Lucky for us, we have a couple decades of experience. And within that, we've learned a few things. some lessons we're still learning, and we continue to learn those same lessons over and over again, but we'll get it right at some point. And we have what we call patterns, right? And so we have patterns that we can talk about in both in implementation and executing towards that design. And we can leverage those to minimize that disruption and those costs. And we can actually carefully work our way through disrupting that ecosystem in a thoughtful way to be able to be isolated or contained, to be scalable, and then manageable. I couldn't quite see the slide over there. To make sure that it's not chaos and that we're just not blowing everything up. So what do these patterns look like? So from a strategy and policy perspective, we've talked a lot about this in different ways this week. You have different ways of viewing things. And from a big picture view, you might be creating a digital health strategy that really is saying, okay, we want to move towards a standard-based, interoperable design. So we're just developing standards, policies and guidelines on electronic medical records or on HIS overall or the functional requirements of particular systems. You might do that at a big picture view, but in real life, as you're executing, you might actually have to consider block by block and look at this from, this particular block is harder to control or is more disruptive, or maybe it's too antiquated but too expensive to replace right now. And so you might have to lean more to the left in this range, and in other cases, you have more control and more ability and more budget, so you can lean to the right and get more to the point where you can say, I probably reversed those, sorry about that, where if it gets to the point where you can say, oh, let's approach this from a standards perspective. So from a strategic perspective, looking at the big picture is nice, but you might actually just have to look at block by block and decide what's best for your context. And there is no one single right answer that fits all the context. It's really dependent on what's going on in your country and what resources you have available to you and what pressures you are under. But these are some ideas for what you might consider when you're thinking about block by block how to approach this. Finicky. There we go. Along with that, and as an additional flavor, a lot of us know this idea and this pattern is thinking about it from that top-down, bottom-up, and middle-out approach. So this is a continuation of the previous slide where we're looking at, what is some of the reasons we might use one approach over the other. And you can do this within each of the areas within your overall architectural design, or you can do this as a whole, right? And so earlier this week in our breakout groups, I heard from folks in Nigeria. I heard from folks in Kenya. I have some experience here in Kenya. I know that everybody doesn't actually do one single thing here. Nobody goes, we're going to come at this completely from top down, or we're going to come at this from completely bottom up. In fact, it's quite a mix, right? So in Nigeria, I hope you guys don't mind me telling your story a little bit. I heard a lot about how they're trying to create some policy and strategic decisions that people can follow, but there's also some autonomy at the state level. And so there's a mix of this kind of organic, bottom-up, come to the big picture design as they're ready, but there's also this top-down pieces where they're trying to do some national systems that everybody can utilize. So they're mixing that approach. In Kenya, they came at this early from a middle-out approach using standards. So Steve Wanier and others in this room, we were all part of developing the first EMR policy standards and guidelines, right? Coming at it from a standards perspective so that people could keep working with their EMR, but then also eventually move it into a standards-based solution that interoperates with everything else, right? So there's different ways to look at this. Oops. Thank you. In software engineering, not to get too far in the weeds, we have other patterns that can be helpful in implementation. So you may be aware of this. This may be just old news for all of you, but there's a common pattern, and there's many other patterns we could talk about, but this is just an example. It's called a strangler pattern. Some people call it a strangler fig pattern because it's actually built, it's actually named after this idea in nature where a strangler fig tree actually takes over an existing tree and grows up around it and eventually strangles and kills the tree that it starts with, right? I know it's a little violent, and maybe I shouldn't be using a violent image here for talking about what we want to do with digital health, but you know, it works. It's what we call it in software engineering. This same pattern can be applied to our architecture. And again, going back to the idea, it's not all or none. And so thinking about it from either the overall architecture, how you approach things, or individual software components, right? So developers and engineers use this to think about how do they refactor or how do they change things into the software to modernize it without disrupting the entire legacy system, right? Because that's just too big of a hurdle. It's too much. And by doing this strangler pattern approach, you can actually minimize your disruption. You lower your risk. It really reduces the complexity of changes that are introduced, and you're delivering business value into your ecosystem a lot sooner. And so thinking about how to help your implementation teams and your engineers think about what are the kind of small bite-sized chunks that you can do in iterations to be doing iterative improvements in your modernization. So I'm probably going to skip these because I want to make sure I have time for my esteemed panelists here. We'll come back to these, and we can use these either in the Q&A or at the lunchtime, ask me anything. But my group at UW has some experience in quite a few countries doing this. And it's just some example slides. You'll have these available to you. But this is just an old example from Haiti we did a few years ago where we started strangling out some of the older architecture that wasn't interoperable. But for now, I'm going to go ahead and hand over to my esteemed colleagues and let them introduce themselves. So we'll start with the folks from Sri Lanka. You want to introduce them? I was like, am I introducing you or you? Okay, thank you. And this, the big one's down, and that was back. Okay. Yeah, and you have to point.
Thank you very much, Jen. Ayubowan, and good morning. I'm Udita Pereira from Sri Lanka. My colleague, Dr. Pradeep Silva, is sitting in the audience. If you have tough questions, I'm sure he will join me in answering them. So let's hopefully move to the next slide here. So like in many countries in the world, Sri Lanka's health system, most of the information systems, they were working in silos, right? Or vertically integrated platforms. So whether it's primary care, tertiary care, secondary care, public health, immunization, everything, they had information systems, but they were not talking to each other. So like you, we realized that we can't go on like this. It's not sustainable, isn't it? So to address this issue, we came up with this Sri Lanka's digital health blueprint, which was funded by the Global Fund. And we had some international technical assistance in developing this. And we came up with this document, which is available online. The diagram you see on the right is actually a very simplified version of it. I encourage you to go and have a look at the original document. But here you can see that in orange is depicted all those siloed legacy systems that I was talking to you about, the points of services. Now how we have plan to integrate all these things is through this National Health Digital Exchange, NHDX. It's a key component of the digital health platform. And you can see there are several other foundation services and DPIs working together to make this happen. And one of the key components of that is, another thing I want to highlight, is the National Electronic Health Record, which is supposed to be our womb-to-tomb health record, capturing all the encounter information a patient would have throughout his life, whether it's primary care, public health, tertiary care, whatever. So how do we do this? When we try to implement our digital health blueprint, we came across several challenges. Let's talk about some of these challenges. We are not going to have time to talk about all of them. Let's take up some of these key challenges. One was, what was going to be our unit of data exchange? Now, we have many different electronic health record systems, EMR systems, and they capture information in very different granular levels, right? So some may need to go into very much detail about smoking, and some EMRs may not really matter. It doesn't really matter. So they capture the information in a different way. They capture different encounters in different ways. And if they start sending this information into the NEHR, although even if they are fire compliant, we would face an issue in compiling this information. So what we thought was we would further standardize the standardization. Instead of sending diverse bundles, we thought of coming up with a salient, clinically relevant summary format, which was incidentally compatible in structure with the IPS. So basically what happens is, in any encounter, let's take an OPD encounter, for example, patient comes with fever, right? So the doctor might record that the patient came with fever, and he might order some lab investigations, he might order a chest x-ray, and based on these findings, he might come to a tentative diagnosis, and he might give you a prescription, right? So all this information are captured in that encounter. So what happens in the EMR side is, the EMR would capture all those fire resources that are generated through that and bundle it together in this format, the structured format, and this bundle will be sent to the NEHR. So this actually simplifies things from the development side, from the EMR development side, because I don't have to really think for this encounter, what are the information that I need to gather? For this encounter, with this different type of encounter, what are the information I need to capture? All of those information, whatever the information available in this format is pulled together, bundled together, and sent to the NEHR. As you can see, there are some headers, required resources, recommended ones, and optional ones. We would have the required ones, obviously, and the recommended ones, or whatever the available ones from the optional ones will be bundled together. So what happens if an encounter doesn't have any required resource? For that, in our implementation guide, we have specified a no resource. If it's not available, we will be sending that, right? I will show that to you when I show you the implementation guide. So this makes it easier from the development from the EMR side. And also, I don't have to really develop a new way to visualize this, because this is an IPS compatible structure, and any IPS viewer can be integrated into an EMR, which means that we don't have to reinvent the wheel. We don't have to develop a new viewer for this. We can reuse the components. Okay. Second challenge. Obviously, our systems were not designed with interoperability in mind. Okay? So we are looking at it as an afterthought. So these EMRs, they don't even have standard international codes. They use their own primary keys. They use their own codes, local codes. So how do we make sense of these diverse local codes? We had to have two different approaches. In the short term, we thought, because we wanted to get this done quickly and to showcase that this is possible, we had a short-term plan to map these local codes to international codes through OCL. However, the long-term view is that our interoperability team will be developing a standard value set with international codes that can be used in EMRs. In the diagram on the right, I just wanted to highlight to you that between the OpenHIM, that is our National Health Digital Exchange, and the EMRs that you see on the top, OCL sits in between and translates these local codes into international codes. Okay, third challenge, the user interfaces. Now, this is something I can't say that we have addressed to our satisfaction. Further development is needed on this side, but when it comes to the interfaces, we have to consider the clinician's input, right? So as clinicians, I'm primarily a clinician, we are used to these beautiful words or syndrome names that we learn in medical school. And when we try to enter those diagnoses into our legacy systems, the ICD-10 search did not, for example, for this syndrome, it doesn't come up with any suggestion. So the clinician has to know what's in the coding system to code it, isn't it? So that's why we moved on to ICD-11, which provides a much user-friendly coding tool. It's Google-like. You type your same syndrome and it gives the suggestion. So this, and even in the other instances in the OPD encounter, if the clinician has to go through thousands of codes to find what he wants, it's going to be difficult. So we need further discussion, improvement from the development side and the clinician side to get together to develop a user interface that is easy to use and has high throughput. Okay, this is the implementation guide. I want to especially thank Richard if he's here and the JMB team. They help us to develop this implementation guide. We have these available online. You can access it through that QR code. We have the no resources that I mentioned to you earlier. If the allergy information and medication requests are not available in a certain encounter, we can send that resource instead. So we use SNOMED GPS in most of our coding, LOINC for laboratory, ICD-11 and ICD-10 for admission diagnosis information. This is, I won't actually show you this live, but internet connection does not permit me to do it. But real time, we are passing data into our national health record. For the moment, only my hospital and 3 other hospitals are sending data because we are at a testing stage. But once the system is in place, and when the production system is in place, we hope all our hundreds of hospitals and primary care and public health services will be passing data like this, and we will be able to capture the encounter data. Okay, so what I want to highlight here is that we focus on the richness of the encounter data. Now, our health system, our public health system is free at the point of service. You don't have to pay anything. It's not insurance-based. It's free. So we have to focus on collecting information that is relevant for the clinician to make a good diagnosis or come to a conclusion based on his past data. So it does not matter having hundreds of millions of records if it just contains appointment information, isn't it? So we need to capture whatever the clinical details that was captured in that encounter as much as possible. So we have worked a lot to define a large amount of data sets and use cases, and we are determined to have capture the information that is necessary for a good shared health record. So we can capture all encounter information, whether it's secondary or tertiary care, OPD clinics, admissions, primary care, screening, immunization, whatever the information is coming from, we capture them. And we capture all the information that is relevant, reason for encounter, diagnosis, lab investigations, prescriptions, radiology, observations, body weight, blood pressure, blood group, whatever is available, procedures, allergy information, plan of care. So this data bundle that I told you that we are sending to the NEHR captures all those information, and it's a huge bundle. There's no possibility of showing you all that in one slide. So I have just highlighted some excerpt. On the top one, you can see the body weight, how we capture that, the prescription information on the right, and on the bottom, all the laboratory investigations, the request and the result, everything is captured in that bundle. Okay, so as you can see, we started somewhere in June this year. Up to now, from 4 hospitals, we have over 2 million records is coming in, and this is, as I mentioned to you, is just in the testing phase. We will be having a production system once the GFATM's project is final. I mean, the funding lines have been realized. Okay, that's it from me. Thank you very much. Over to the next speaker. Oh yeah. Thank you, Chris.
Hi, I'm Taufik from Indonesia. I'm the leading for the technical advice for the Ministry of Health from USAID project, especially from CISO area. So I'm here with many friends from especially Fikri, Saldi, Mas Anis, and a lot of friends from Indonesia come here to join about the conference. So we start about the top down here. It's like the blueprint area. We encourage all donors and support must be come from a technical perspective of blueprint. Since 2021, we have the first blueprint of digital strategy. And now we trying to move for the seconds 2025 until 2039. And this is the good progress about how we put into strategically, especially for the vision and for the next phase of the implementation in digital health in Indonesia. So if you want to know when the release of the 2029 and 2025 of the blueprint, maybe tomorrow you can meet Setiaji and you can ask when exactly the date to release of the blueprint. Next. So in what levels we are achieved now? In 2021 and 2024, we are receiving mandate to integrate data and also to utilize of the electronic health record to one national exchange platform. We call it Satu Sehat. Number of facilities around more than 60,000 facilities total, and more than 60% of the facility already registered to Satu Sehat platform. And also they already connected and integrate more than 30% number. Next. So in this page, I want to make sure how we utilize our blueprint and how we explain the standardization and interoperability is currently working in Indonesia. We utilize of terminology standard. We combine with the equity with a global adoption standard, especially from FHIR, yeah, you know the persons here, and we adopt the ICD, including ICD-9, ICD-10, and also SNOMED City. We are the member of the SNOMED City in currently, and also we utilize of the medical and drugs and also medical equipments standard. We adopt from the UK NHS as the terminology, or sorry, for the data model. And we adopt the lawing as well, DICOM, and we utilize OpenSIE standard here, especially master patient registry or provider registry. We utilize of the facility registry and we utilize of the health worker registry itself. And the right side, we can show the document has been published by Ministry of Health, such as like the playbook, we call it like playbook, or implementation guideline. There are separate things here. Document of the implementation guideline and also the document of the technicals, we call it like web API collection here. Next. So we start with the use case. Why interoperability is important? Because we want to utilize, we want to solve the problem from the facility and health worker problem. Previously, we adopt interoperability because it's just jargon. Currently, we have to mention what is the solution here. Number of health worker and facilities, they have their own system. And they have their own time only for data enter. So here, interoperability, we want to publish interoperability not only to reduplicate of data entry. We want to make a single data entry and share to another legacy system or existing system in our facility level. So this is the part of the sample we can show here, the left side EMR, and we utilize our interoperability layer and utilize from the OpenSIE concept. And also the legacy system, we call it like TB information system, and goes to the Satu Sehat Share Health Record Data Exchange platform. Next. So what we are doing here, especially, is more technical. Especially if we talk about the interoperability, we split into two groups, standard development and interoperability development. Left side, we adopt, is like the alignment with DAK adoption, because in TB previously we don't have the TB DAK previously, just released around May this year. So we adopt the DAK from ANC, how we define the use case, how we identify the metadata or data set, We identify a variable or data element, for example, and we combine with the existing variable has been published by facility or EMR or ESR in that area. And that part, in parallel, we develop the mediator. It's like interoperability layers, levels, and we adopt the synchronization from conceptual of the OpenSIE under OpenHIM product. So in this TB, we decide to utilize our context into 4 submodules about registrations, laboratory, and also follow-up action for the patient TB. This is the pace we currently replicate to another health program use case. Next. So if you go here, I think it's very complex. If you mention what tools do you using right now, the most tools currently we are using is only Google Spreadsheet. It's like the simple way. Why? We love the open source. We love the utilize of the free of charge of the applications. From the beginning, we define the scope. We combine with the Ministry of Health, Center for Data and Digital Technology Office as well. And go to the right side, number 2, interoperability development. We map the file resource. We made it manually. Tools is depend. If you want to see the terminology, open the Google, open the Snowmed City browser, open the Logging browser, ICD browser, and Fire browser as well. It's manually, but we excited to do it. I hope we can see another tools to make a spirit and good results to combine the everything's about interoperability here. And we go to Simplifier, we publish into Simplifier, we publish into Satu portal, we publish to another concept of the PDF or another tools. Currently, we are working on it. And next is about who is the persons here. In Indonesia, we call it like the many supporter, donors, USAID, World Bank, WHO, BMGF, and many working to support on this area. And we utilize everything only for the how we adopt the standard and adaptation to the standard itself. Next. And what is the results? If we go deep dive about the TB program, this is the number. If you mention how many Snowmed city, 9. How many logging code we can support of the TB program for the person with TB symptom, this is the number. Why? Because we are calculate and summarize based on the use case. And also, how many number fire resource currently we are using for the TB? This is the number as well. Patient-based clinical financial is next step because we want to calculate billing and claim for the TB use case. And if you see the bottom levels, we receive many support from not only for the terminal standard, but also from existing organizations, from WHO ATC about anatomical therapeutic chemicals, CVS got system for vaccination if you compare with the vaccination program itself. Next. This is for the existing health program, not only for the TB. You can read here. I hope WHO able to provide another DAK, like rabies, mental health, or another use case here, like Ilisari, for example. Next. And what is the result here? If you go to the fire and interoperability, this is the product. We utilize of the OpenHIM from OpenSIE, and this is the global public goods here. And the left side is like we deploy into many use cases, national levels, subnational levels. And if we go to the approach, I think it's very, very costly. One is about technical documentation, a lot of support, only for the interpretation of, only for the implementation guideline, deploy of the web API collection, deploy of the IG, for example, but we have to support of the connected. It's very important. We cannot mention, oh, this is the published version. We have to check again based on the conceptual. Next, this is the results of the conditions. How we utilize everything's here. Currently, we are having to mention client data from multi-data source currently enter to the EMR or EHR real-time, integrated with the SITB or TB program and Satu Sehat. Health worker can easily access to the data to view previous treatment medication. Number of the saving time is 50% of reduced. I think this is the good progress currently we are doing, and we currently support for another scale up, especially with SIP, how to integrate and how interoperable between TB and SIP itself. Next. Thank you.
Hi, 10 minutes, great, thank you. That was my question. All right, hi, my name's Fred Hirsch. I'm from Google Health. I think you've met me before. I'm the product manager with Open Health Stack, and I think we've heard some really great examples of how countries are really building the blueprints and thinking about these strategies. And what I'm going to talk a little bit about is some of our work with Open Health Stack, and maybe it's more of the middle out or some of the bottom up approaches and how all of these things connect together. So go through these slides pretty quickly. We've heard all about interoperability through open standards, architectures, and technologies is really widely endorsed. We're trying to achieve, quality person-centric care. And this has been a theme for a long time. The latest iteration is our full stack, work together. But the reality, as we're all grappling with a little bit, is that all standards, not just about fire, but we know that standards can be difficult to adopt. And so when we started thinking about this problem at Google, we thought, well, how can we try to reduce some of that technical complexity, right, to make it easier to work with standards and lower the barrier for entry for developers everywhere, okay? And so if you think about today, there's a lot of this, there's a lot of activity that happens, the submerged iceberg there. There's a lot of code being maintained or rebuilt or other things. And so we wanted to try to really take this enabling infrastructure approach, right? So make it easier to build to standards, provide features and other things that really solve problems, that can promote the adoption of these interoperable solutions and enable local innovation, right? Like we really want to kind of see ecosystems kind of flourish around the ability to now build to a standard, right? Instead of building to a custom data model, we're building to a standard. And so that's really what Open Health Stack is. Next slide. And we launched this back in, I think, March of last year, and it's a suite of open source components. These are all digital public goods that really helps developers to build these next generation healthcare apps faster. So these are things that promote patient-centric care because they're leveraging FHIR. We have mobile tools for building offline capable, secure apps. And then we also focus on ensuring privacy, so through enforcing access control policies, and then making it easier to generate the insights from that data. So we really try to drive better decision-making and better data use, right? And these have all been designed to meet the unique needs of low-resource settings, but it's FHIR, right? So offline capabilities, being able to deploy to national data centers, we heard that earlier. It doesn't have to go to the cloud. This is not a cloud pitch at all, but there are definitely benefits for that. But in the meantime, we need to be able to deploy horizontally scalable pipelines into national data centers. Next slide. And as you've heard, it's been a great privilege for us working together with WHO and the whole ecosystem of partners to really help to accelerate this patient-centric digital health transformation. Next slide. And so these is, the parts in the purple are the components. And the important thing here is that these are building blocks. So developers use them. They can be used individually for solving different problems. And we heard some examples of that yesterday. And the things in the blue are the solutions or the platforms or the products that others are developing. So we're not building products or solutions to try to compete with what's out there. We're trying to build the enabling infrastructure that can either be integrated into existing systems or can be the foundation for new systems that get built. So next slide. And as you saw some examples last night, but it's been really exciting to see this kind of growing set of partners building solutions on OHS. Next slide. Okay. So when we're talking about this panel, I think we get asked this question a lot, right? And I think about this as how are we transitioning really from this kind of program-centric view to this patient-centric approach? And I think it's really important that we acknowledge that we really want to leverage some of the existing investments whilst planning this transition, right? So I'm just going to take you through some patterns, if you like, that we've certainly seen. Can you step back a slide? I think. Okay, we lost the. Okay, go. Sorry. So let's imagine. All right, we were going to start on the right side over there. You've got a non-Fire-based app, you know, in your country already, but you want to be migrating to Fire. Well, we saw last night there are existing tools like OpenHIM. We've heard about that. OpenFN and others that can help you to transform that data. Now I've got that data in a Fire format. I want to really be able to analyze that data effectively. This is where the Fire data pipes helps us to transform that into SQL queryable data warehouses. I can now build my dashboards. I can use that rich patient data, you know, that my colleague from Sri Lanka talked about, you know, to understand, you know, do data science activities and other things, maybe even some machine learning, feature extraction, right? It's rich patient data. That's really one of the value propositions of moving towards this patient-centric model. Next, we'll see where we get to. And then I might decide that I want to release a new application. Well, now I can build that directly to the standard. I could leverage something like the Android Fire SDK. I can build it in-house, or I can work with others to do that as well. Next slide. But what if I've got a whole set of OpenMRS implementations or other systems, and they may or may not, but like we saw yesterday with OpenMRS, if they expose a Fire API, so if there's a Fire facade around that, now I can, next one, I can connect that, oh that's, okay, that's from the, I can now connect that up with my application that I've built because it's Fire native. I can now sync that because it's using Fire as its medium of exchange. Next slide, let's see what this looks like. And then the Fire data pipes, as we heard, you know, that can also then actually use that Fire facade, that Fire API, and I can be powering this rich data. Next, okay. But what about if I've got a big health management information system like DHIS2? It's very common, obviously, very widely used and provides a lot of value. Well, it's got its own APIs. So let's see. So I can, you know, connect that directly to a Fire server using some of the APIs that it provides. I can also use like the OpenHIM or these other like mediators that exist. But likewise, I can then, let's say I'm running these analytics workloads, I could then be calculating those aggregates using a OpenHIM or a tool like OpenFN and be landing those in DHIS2. So now what I've got is I've got the value of this full, you know, end-to-end patient-centric model of care. I've got this rich data that I can be analyzing, you know, in near real time. Maybe I'm able to now distribute decision-making more down to different levels, but I'm still able to get that data, potentially a higher quality data, into some of these systems. Next slide. I don't think we have time for this. So we have a video that we can show you, maybe if you come to the Ask Me Anything session, but I'll just wrap up. So next slide. So, you know, I didn't want to give the impression that this is a solved problem, right? But I think you've heard that actually there are lots of people that are really solving this very effectively. And there's some great tools, and we saw last night some great examples of how innovators, technologists are leveraging Fire in great ways. And I think it's really exciting. And so if we think about this transition, right, it's not, you know, Fire isn't the silver bullet. We heard that from Graham as well. You know, this isn't going to solve all of our problems. There's going to be legacy data quality issues and other things that we need to really think about and grapple with. But perhaps, you know, moving to Fire and thinking about all the structure and enforcing that structure and the validation that it provides, you know, might lead to higher quality data collection, richer data sources we thought for decision making and thinking about that data use question. And that by using some of this enabling infrastructure, now we have the opportunity to potentially try to address some of those issues. So there's less of that technical debt maybe that's sitting under the iceberg, and we can try to resolve those issues internally. If you'd like to learn more about Open Health Stack, you can scan that QR code, ohs.dev. If you have technical people in your organizations or in your countries that might be interested in this, this is really about enabling that local innovation and that capacity. And thank you very much.
Do we have time for a few questions? I think we have about 5 minutes. Yeah? Okay. Any questions out there for any of our panelists? And I don't know if we had the QR code for questions either. Any questions coming on that? Okay. Oh, she's got you. Okay.
Hello, good morning. I'm Naveen. So question is to the team member from Sri Lanka. So you mentioned about using IPS for patient summaries and that what your plans to store in the NEHR. So you plan to store this as documents which gets updated. Like for example, let's say a EMR which is running in a hospital takes the copy of the IPS from your NEHR and let's say captures an additional new encounter. Does the same IPS file get updated with this information, or is this IPS for every encounter stored separately as a document?
Thank you very much for the question. As I mentioned, it is compatible in structure with IPS, but we are not using it the way the IPS is meant to be used. So IPS is a point of time, what is the complete history of the patient. So we are using a format that is compatible with it to capture the encounter information at that visit, right? So let's say today I will go to the OPD doctor and I have my encounter recorded and it is stored there in EHR. And in about 1 week, the patient comes back, the doctor will be able to access the NEHR and see the previous encounter information, and it will be displayed in a compatible viewer with the IPS so that he can see what happened in that visit. So this visit obviously is a new visit, and we don't want to change anything that happened in that encounter. So what will happen in this encounter, another bundle will be created and it will be sent to the NEHR. So it will have, at different points of time, different encounters, but they are all captured in a format, structure that is compatible with the IPS. Is that clear?
Thank you. This is Charlie Maire from Elizabeth Grazer Pediatric Foundation. I have 2 questions, one from Sri Lanka. I really like the innovation to say getting, data points from a facility and then pushing it at a central level. And my understanding is that you are piloting, is it 2 sites? Yes, so I just wanted also from experience in the countries which we work with, when you're going that approach to say data points across the hospital-wide, and then you're pushing, and when you look at scaling, there are issues which comes in, where you look from 2 to 100 to 800 to 1,000, you consider now the connectivity, the syncing and so on, and then you consider the computing for those transformations so that you can translate that data into analytics for your use. So I don't know whether you have already use cases within the standards. The second question goes to Google for Health. For the OpenStack, we have done ETLs like in Malawi, nationwide, for over 800 facilities. When you get that kind of data, the first issue we have, because you have different data point of areas, you need the integrity checks across every steps. So that actually increases the complexity of your national network when you're hosting on-prem within a country. I don't know, within OpenStack, have you already brought in those integrity checks everywhere you're doing some ETL? I'm just curious on that. Thank you.
Thank you very much. For the first part of the question, yes, we are very much aware about the complexity and the resources needed to scale it up. And we are hoping that we will be getting continuous support both from the technical side as well as from the funding from GFATM. And they will be providing us all these facilities or the technical expertise to make sure that our systems are compatible with the large amount of data that we are thinking of coming out. So yes, definitely that's in the mind, and we are trying very best to solve that issue. And we'll be happy to share that information with all of you, our experience when that actually comes to fruition. Thanks.
Yeah, thanks for the question. So with the fire data pipes that we have at the moment, it's more focusing on that infrastructure problem. How do we create horizontally scalable pipelines that can handle data that's going to grow very, very quickly? So the short answer to your question is no, we don't have those types of quality checks. But one thing, as you saw last night, like from the University of Washington, the Digi team, they've been doing a lot of work on once you've got that data, if you're assuming it's kind of coming as a fire data source, once I've now started to flatten that data and I have it in this SQL on fire kind of projection, so now I have a standard schema, then what they were talking about last night was building out all the different star modeling tables, and presumably some data quality checks and other things happens as part of that. So I think there's a whole layer of scripts and others, tools that can help to solve these problems. Because I mean, that's the point. These are kind of common problems. And so one of the advantages, if we are leveraging FHIR as the standard, and then using a standards-based pipeline to transform that data, I now have a standards representation of that data. And so then if those types of data integrity checks or other things get developed once, they become reusable. And so you can start to kind of imagine that there is other opportunities to find reusable pieces to solve common problems. So we can talk more about that offline, but I think, thanks for the question.
I think that brings us to the end of our time. I'm looking for a signal. Yeah? Okay. Thank you.